Hey, so this is for day 16, absolute value functions, part 2. We're investigating distance as a function. So function f is the absolute value function. It gives the absolute value of x, and that's what these vertical bars mean, from 0. This is just asking how far from 0 is our x value. The graph of function f is a v-shape with two lines converging at 0, 0, because how far away from 0 is 1? Well, it's 1 away. How far away from 0 is negative 1? Well, it's also 1 away. How far away from 0 is 8? 8. How far away from 0 is negative 4? 4. So that's how these points are plotted on here. How far away from 0 is 0? Well, it's 0. This point right here we call the vertex of the graph. It's the point where a graph changes direction from going down to going up, or the other way around. It could be going up and then down as well, if there was a negative in front of there. We can also think of a function like f as a piecewise function because different rules apply when x is less than 0 and when x is greater than 0. What we could do is we could say that f of x is equal to squiggle negative x for x less than 0, and just x for x greater than or equal to 0. Now, we can calculate the difference between x and 4 by calculating x minus 4. Since distance cannot be negative, what we would want to do is take the absolute value of that difference. So p of x right here is showing us how far each of these numbers as our input is from 4. So how far away from 4 is 8? Well, it's 4 away. How far away from 4 is 2? Well, it's 2 to the left, but distance doesn't matter which direction we're going, so it's 2. How far away from 4 is negative 4? Well, that would be 8 to the left, but again, our absolute value function doesn't care what direction we're going. Distances aren't negative, so it's 8. Now suppose we want to find the distance between x and negative 4. What we would do is find the difference of x and negative 4 by calculating, and I don't know why that was missing, x minus negative 4, which comes out to be x plus 4. Distance cannot be negative, so let's find the absolute value. So what it would happen then is we would have p of x is equal to the absolute value of x plus 4. Now, when it was x minus 4, my vertex was here at 4. For this function, it would actually be over here at negative 4 instead. So let's talk about this. The term elevation is often used to describe the height of a place, such as a city, a mountain, or a valley, compared to sea level. For example, the city of Houston, Texas has an elevation of 105 feet. The surface of the sea has an elevation of 0 feet. Some places are below sea level, so their elevations are negative values. The table shows the elevation E of several towns. Function f gives the vertical distance of each town from sea level. Again, distance cannot be negative. So, how far from sea level is 12.1? Well, it's 12.1. How far from sea level is negative 180? Well, it's 180. Write an equation to represent f of E. Well, I mean, f of E would just be the absolute value of whatever the elevation is, because negative 180, absolute value of negative 180 is positive 180. Number 3, two towns have different elevations, but when the elevations are used as inputs of f of E, they both produce outputs of 25. What are the elevations of the two towns? So wait a minute, they started off at different elevations, but they're both the same distance from sea level. What could that possibly mean? If you have any questions, let me know. Have a great day. Goodbye.